I'm selecting recording this video. Okay, don't deactivate this option. Okay, the next is, as I told, we are discussing about the application of your embedded system here. Okay, so where I stopped in the home automation and security. Okay, home automation security in the sense, as we seen, the air conditioner detection, intruder the detection alarms. That is, whenever the robbery it is happens, before that we are going to use the lock. Whenever the thief is come to the house, if anything happens, at that time it is going to make alarm. Okay, and as well as cameras, television cameras. That is nothing but CCTVs. Okay, all these are your home automated and security system applications of embedded system. Again, in the automotive industries, we are going to use anti-lock braking system, okay, ignition systems, automatic navigation system. Automatic navigation system is nothing but nowadays we are seeing what digital speedometer in your two-wheeler vehicle or automatic navigation system is nothing but your Google Map. Okay, Google Map is nothing but what, wherever you want to go for destination, you need route. Okay, so how we are going to use? We are going to use as a Google Map if you want to visit to new places or any good places. If you want without knowing any navigation means, you are going to use the Google Map in order to reach your destination. So at that time also we are going to use the this is one more application of your embedded system here. Okay, and next in telecom, in communication field. Communication field is nothing but about your cellular phones, telephones. Okay, handsets, multimedia applications. Okay, multimedia is nothing but what maybe your music record, your audio recorder, tape recorder. All nowadays, all it becomes the digital. Nothing but again, those are applications of your embedded system only. Multimedia applications, handset, nothing but your headphone. Okay, headphone, microphone. All these are all applications of your, again, it is an embedded system in the communication field. That is nothing but in the cellular field. Okay, and again, when you come into the computer peripherals is nothing but, as you know, printers, scanners. Printer is nothing but what, you want to take the printout of your soft copy. Okay, so again, the job of the printer is nothing but it is going to perform the printing your paper, whatever you want to print. That if you want to if you want to take printout of your image, that can it will print. If you want to take document printout, it will print that one. Based on that the requirement, the printer will print. Scanner is nothing but what, it will convert your hard copy into soft copy. Okay, fax machine is nothing but if you want to send your data, if you want to what for example, you want to share your data, means if you want to share your document from one place to another place, to far place, at that time you are going to use fax machine, so that it will scan your hard document and it will transmit the data to your destination. For example, if it is for if I take a place, A is my one source place and B is my destination place. The distance between A and B, it may be 150 kilometers, means what it is. If I want to transmit my document from A place to B for a next 5 to 10 minutes, it will not happen. At that time, what will do? You are going to use fax machine. The job of fax machine is nothing but it will scan your hard copy. Okay, it will scan your hard copy and it will transmit the data to the network and it will reach to your destination by dialing the numbers. Okay, that is nothing but fax machine here. Okay, and again when you come into the computer networking system, in the computer networking system, that is nothing but actually that is if you want in the network, if you want the internet connection, at that time we are going to use routers. Okay, routers is nothing but what, it acts as a gateway from your house to the telephone station or your Airtel station, from wherever the network you connect, geo station. Okay, switches, hubs, all these are again comes under the computer network application here. Okay, and again in the healthcare is nothing but, as you see nowadays, whatever if you want, if you want to take a report of your anything, if you want to take the report of your health, means we are going to use what, scanning, nothing but what, again that it comes under the embedded system application, scanning or x-rays. Okay, and again some of the report, that is blood test, blood sample test, ECG machine. Okay, ECG machine. Okay, all that is whatever you want to collect the samples, again you need to generate the report, all that you require the machines. The machines is nothing but what, that is embedded system only. Okay, ECG machine, art related machine, that is whatever you're going to ECG machine, all this are comes under the embedded system application here. Okay, again if you come into the labs, means actually in the, if you come into the lab for second year, you're going to use the you have analog communication lab, sorry, analog lab and digital lab. In the analog lab we are going to use the CRO. CRO is nothing but cathode ray oscillator, in order to find out the detect the output or input waveform. Okay, amplitude as well as time, means we are going to use the CRO in order to display your waveform input amplitude as well as output amplitude. At that time we are going to use that instrument called CRO here. Okay, multimeter, digital meter, again that are all comes under the application of your embedded system here. Logic analyzer, again that is nothing but by giving the input values. But when in the digital lab we are going to supply the digital values, nothing but input or output. As we know that, if I take it as example, my AND gate. Okay, I need to give the input. I have two inputs and one output. I need to supply the input, that is A and B. So this is A and this is my B here. Okay, I want to get the output. At that time I need to measure. I need to give the input, my input terminals of AND gate, as well as I need to analyze the output of your AND gate. At that time we are going to logic analyzers. Okay, all these are applications for your embedded system here. Okay, again when you come into the banking field is nothing but what, ATM machine. You very well know the ATM machine is nothing but what, in order to withdraw the cash, as well as nowadays we can deposit the cash also. Okay, not only we can withdraw, we can deposit the cash also. That is two in one option. And one more thing, automatic printing machine. When you are insert the passbook, okay, all your records, it is going to print on your passbook. Again that is what, that is printing machine, where we are going to use in the bank application. Okay, printing machine is nothing but what, whenever you are going to insert your passbook, it will going to record all your histories data. Okay, that is what you are going to use, that is printing machine. Okay, that is also a embedded system in the bank field or bank domain. Point of sale is nothing but what, whenever you are going to go for shopping, okay, at that time you are going to swipe your debit card or credit card. At that time we call that as a point of sale. Point of sale is nothing but what, we require some machine in order to swipe your credit card or debit card in order to pay for your offline shop. That is what we call that as a point of sale. Okay, again all these are applications comes in the embedded system only. Again when you we know that barcode is nothing but what, we have some bar on the, we have some straight lines on the papers, nothing but it will read this barcode and it will generate the data. Okay, for example, yes, okay, so he means some line will be there. By using that lines, we are going to scan the bar, so it will generate the respective data. Means in our, how can it generate the data? By passing the laser light on this bar, and it will generate the respective data on your computer. Nothing but we are going to use barcode in various applications. Nothing but your shop line, or sorry, shoppings or your grocery items. Okay, so many fields we are going to use these barcodes. Smart card reader is nothing but what, nowadays we are going to use the smart card is nothing but NFC smart card. NFC is nothing but contactless. That is contactless NFC. Okay, that is we call that a smart card. Without swiping, we can if I simply tap, it will fetch you all your data, and you can pay to your retailer. Nothing but smart card readers, handheld device. All these are nothing but again all these are the applications of your embedded system here. Is it clear? Is it clear?
Yes, sir. Yes, sir.
Okay, so these are the major applications of your embedded system. Now, let us move towards the overview of my microcontroller. Okay, overview is nothing but what just I tell embedded system is nothing but if I tell embedded system is nothing but I am going to use microcontroller, microprocessor. But in the embedded system, we use only the microcontroller as a IC. Okay, this is my IC. IC is nothing but in that we have all the resources in the single chip. Nothing but this is my IC, nothing but integrated circuit. Okay, here if I tell microcontroller, because the microcontroller is nothing but your CPU. What is the job of the CPU? Can anybody tell? What do you mean by CPU? What it will perform? Okay, can you tell me what is the expansion of the CPU? Expansion of the CPU. What is the expansion of the CPU?
Central processing unit.
Yes. Okay. Central processing unit is nothing but it is having the control unit as well as the ALU unit. Okay. So it is going to perform not only ALU, it has to perform the control. Control is nothing but what? It has to fetch the data, it has to read the data. Okay. That is, we call that as a control. Okay. So here, if I tell the microcontroller, inside the microcontroller, what are the components present in the microcontroller? Okay, that is what we are going to discuss about the microcontroller here. Okay, the overview of your microcontroller is nothing but if I take this is my complete chip. Okay, inside the microcontroller we have the memory because in order to store the data, in order to fetch the data, in order to read the data, in order to write the data from the CPU or to the CPU. Okay, in order to store the data, we are going to use memory, the memory which is present inside of your microcontroller IC. System call is nothing but your CPU. Okay, this is nothing but your CPU. CPU is nothing but it is going to perform arithmetic and logical operations as well as it has to perform the control operation. Control operation is nothing but it has to going to fetch the data. Fetch the data is nothing but read operation. Read operation, write operation. Okay, all these are operations it is going to perform inside the CPU. Okay, along with that, the CPU it is having the input ports as well as output ports. Okay, ports is nothing but pins. Okay, the pins where we are going to interface my input device as well as my output device here. Okay, ports is nothing but what? That is the pin present outside of your IC. Pins. I have to connect, no? I need to connect my device. Nothing but device in the sense, for example, in the laptop or PC. In the laptop or PC, I am going to connect my mouse. I need to connect my mouse, keypad, okay, a keyboard. Okay, all these printers I need to connect to my CPU means I require ports. Okay, so ports is nothing but I'm going to connect the ports of the mouse to the pin of your ICs. That is what we call that as a, if I connect input device, it will act as a input ports. If I connect output device, nothing but printer or monitor, that pins will act as a output ports here. Okay, input port is nothing but if I connect keyboard or mouse any input device, if I connect sensors, okay, if I connect any input sensors or any mouse, if I connect all the input device, whenever I'm going to connect the input device, those pins will act as a input ports. Okay, for the same thing, if I connect output device is nothing but your LED device, stepper motor, nothing but motor. Generally we call motor DC motor, stepper motor. Okay, all these are all output device. Okay, and buzzer, all these are output device. Whenever we connect this output device, whenever we are going to connect this output device to the pin of your microcontroller, means those pins will act as a output ports. Okay, it depends on the device. Okay, it will depends on the device. If you connect input device, it will act as an input ports. If you connect output device, it will act as a output port here. Okay, and along with that, we have a communication interface. Communication interface in the sense, inside of your microcontroller, we have UART communication protocol, I2C inter-intra communication protocol, CAN protocol, control area network. Communication protocol. Communication protocol is nothing but in order to transfer the data. If the CPU wants to share the data to your device or outside the world, at that time I need some communication protocol. At that time we are going to use UART. UART is nothing but universal asynchronous receiver transmitter, inter-intra communication, I2C. This is a one type of communication protocol, CAN protocol. All these are a wide communication protocol. Okay, so all this means without device, nothing but without input device and output device. The device will not present inside of your IC. Okay, the protocols or memory or ports. Generally we call that as a ports. Okay, whenever you're going to connect input device, it will becomes input port. If you connect output device, it becomes output port here. Okay, if I want to tell the microcontroller means it is having the pins, nothing but these pins will act as a input ports. Okay, and as well as it will act as a output ports here. Nothing but these are pins of my IC. Okay, and along with that, inside your microcontroller, as I told, sorry, let me write properly over here. If I take, this is my complete IC. Inside the IC, if I make partition, this is CPU will be present inside of your IC. Memory is present inside of your IC. Okay, communication protocol. Okay, that is nothing but yeah, that is nothing but your UART, I2C, CAN protocol, communication protocol, as well as nothing but we call this as a peripherals. We call this as a peripherals. Along with that communication protocol, timers will be there. Timers is also present. Okay, all these are peripherals only. Means it will act as in order to make communication between the CPU as well as output device outside of the environment. Okay, and here again, if you come into here, again we have what here ports we have. Ports is nothing but that is the pins of your IC. Okay, and memory, if you come into the memory, we have RAM memory, ROM memory, all these types of memory present inside of your IC. This is complete integrated one IC. Inside the IC, all this will be present. That is what we call this as a microcontroller. Microcontroller is nothing but it is a small in size and it will able to control all these device inside. That is what we call that as a microcontroller. So these are the elements of your embedded system. Okay, these are the basic elements of your embedded system here. Okay, and next is next is what? Core of the embedded system here. Are you following me?
Yes, sir.
Yes, sir.
Had your lunch?
Yes, sir.
No, sir.
Yes, sir.
Okay. Okay, let me ask some cross questions in order to wake up you who had lunch now. For them, let them
Have
wake
you
up.
had, sir?
Yes, tell me.
Had your lunch, sir?
No, still I didn't have. Okay, let me finish. After that, I will finish.
Okay.
Okay.
Yes, sir.
And next is I'm going to discuss about the core of the embedded system. Core is nothing but the main, very essential or main of the embedded system. Core is nothing but what? Very main part of the embedded system. Okay, as I told, how can we classify the embedded system? As I told, we can classify based on the generation. Okay, based on the complexity and performance. Okay, based on the triggering, based on the deterministic characteristics. Okay, based on that concept, we categorize the embedded system here. Now, again, if apart from that, what is the main thing of your embedded system? Main thing is that is what we call that as a core. Core is nothing but what is the deep main. We call that as a main of main. Core is nothing but main. Okay. What is the main thing of your embedded system? Here, as we know, main core of the embedded system is nothing but as I discussed, the microprocessor. Microprocessor actually we use in the PC or laptop that will not come more in the embedded system because it will perform multiple tasks. No? So microprocessor that much it will not come into the picture whenever you are going to discuss about the microprocessor. Okay, but it is also a sometimes we call the microcontroller as a microprocessor. In some cases, we call the microcontroller as a microprocessor because based on the complexity. When complexity is increases, then instead of microcontroller, we are going to call that as a microprocessors. Okay, based on the design. But normally we use PC and laptop, and sometimes we very rarely call based on the complexity. Okay, and microcontroller actually we call nothing but the core of the embedded system is nothing but about the microcontroller is along with the digital signal processor is nothing but again whatever you are if you want to see any images because in the if for example let me take it as example of Windows. Okay, Windows is nothing but that is an operating system. In the Windows, if I want to interact my applications, I am going to use GUI. GUI is nothing but graphical user interface. Okay, the user, if I click on the my computer icon, if I click on the my computer icon, he can what he can open his he can open the window and he can interact whatever the files he can perform the operations. Nothing but if I want to perform any operations, I am going to use some type of icon. This is nothing but GUI, graphical, means the user can interact with this graphical notation in order to perform the task. That is what we call that as a GUI. Okay, so if I want to perform the if in order to perform this image, if I want to generate this type of image, okay, because the user wants to communicate, the user wants to interact with the system. At that time, we are going to use this GUI applications. So how it is going to based on the digital signal processor. Okay, digital signal processor is nothing but what again it is going to generate the images. Okay, at that time we are going to use this type of processor. Okay, whenever you are going to deal with the image things, at that time we are going to use this type of processor. Image thing of processor means at that time we are going to use the processor called digital signal processor here. Okay, and sometimes we are going to use the programmable logical device, application specific integrated circuit. Okay, all these are if you go on, all these are all again the part of the embedded system. If the design or requirement of your is complexity is more means at that time only we are going to use this type of processor. Again, all these are all processor. As I told, no, the microprocessor we again sometimes we call this instead of microcontroller we call that microprocessor because based on that design complexity. If the complexity is more, at that time we call that as a processor. Okay, here when the complexity is increases, the core of the embedded system is becomes more. At that time we are going to use this type of processor, that is programmable logic device, application specific integrated circuit. All these are all processor only. Okay, all these are all processor only, where it is going to perform the single task, because in the single task means again we need to consider the design and requirement. Based on the design and requirement, we are going to use this type of processor in the embedded system here. But microcontroller will come into the picture for small application or medium scale application. But if we keep on increase the complexity, at that time only we are going to use this type of processor called programmable logic device, application specific integrated circuit. Okay, and next is commercial off-the-shelf components. It's nothing but COTS. COTS is nothing but before the if I go 10 years back. Okay, if I want to measure the temperature, I need to measure the temperature, and it is going to perform, it has to generate some signal. Okay, if I want to measure the room temperature means nowadays we are going to use the sensors, temperature sensors we are going to use nowadays. But if I go back 10 years or 15 years back, we don't have this sensor concept. Okay, in order to design this sensor, again we need to build the circuit. Okay, we need to build the circuit for designing of your sensors. Okay, nowadays for all type of measuring the input device and output, in order to measure your input analog systems. Okay, in order to measure your input analog signals, we are going to use some chips. That is nothing but we call that as a commercial off-the-shelf component. Commercial off-the-shelf component in the sense, for each and everything we are getting small ICs. Okay, that nothing but has your Bluetooth IC. Okay, that is Bluetooth IC that is present in your mobile phones in order to share your data. Okay, and sometimes if I want to sometimes if you want to know the weather report, how will you know? You should have the sensor in your mobile phones, so that only it will display your weather report on your mobile. So for each and everything we are going to use the IC here. Okay, that is the concept of commercial off-the-shelf components. Okay, so these are all are the core of your embedded system. Okay, these are all are the your core of the embedded system here. Okay, not need much worry about that. Just I express to what do you mean by the embedded system here. Okay, let me go to the next is microprocessor versus microcontroller here. Okay, so now we will get clarity on the microprocessor and microcontroller. Okay, now I'm going to discuss what do you mean by microprocessor. Microprocessor is nothing but, as I told, it is only the CPU. See here, as you've seen in this blue color block diagram, this is nothing but only CPU. It will only perform ALU operation. That is what we call that as a microprocessor. Okay, if I want RAM, ROM or IO port, timer, serial COM port, all if it is requirements, I need to connect externally. I need to connect externally to my CPU. Okay, I need to connect externally to my CPU. Okay, through my data bus or address bus. Why the address bus? In order to identify, let me take this address bus of RAM is 1 and address of your ROM is 2. Address of your IO port is 3. Okay, and timer it will have 4 and the address for your serial COM is 4. In order to identify which device it has to communicate means, first it will send the address value to your processor. Okay, that is what we call that as a microprocessor. Then it will start to fetch the data on the specific device. Okay, whenever the CPU wants to fetch the data, we call that as a read operation. Okay, but after performing the ALU operation, again it is going to send the data to the respective device. Okay, that is we call that as a write operation. Okay, so read operation is nothing but whatever the data present in your memory, it has to read from your memory to CPU. We call that as a read operation. Okay, after performing the addition, for example, if I take C is equal to A plus B, in this example, this value of variable A, I'm going to store in the 100 memory location, and variable B, I'm going to store in the 101 memory location. Okay, it will fetch the value of the variable using this memory locations 100 and 101. Okay, so if I want to fetch the data, that we call that as a read operation, because I want to read the values now. Okay, after that what I have to do? I need to perform a plus b addition. I need to perform addition operation. Okay, I need to perform the addition operation. How can I perform the addition operation? Using ALU, nothing but your CPU will perform the addition operation. The result it has to send. Where it has to send? To your C variable. It has to send the C variable. Nothing but that is write operation here. Okay, so all these things it is going to happen inside of your computer. Okay, that is what we call that as a microprocessor. Example for your microprocessor is Intel 86, Motorola. Nowadays you have dual core, quad core. All these are all example of your microprocessor. i3, i5, i7. Okay, all these are all example of your microprocessor only. Is it clear?
Yes, sir.
Now, if you come into the microcontroller, as I told, microcontroller is nothing but everything it is going to present inside on the single IC. Okay, that is what we call that as a microcontroller. If I take this complete one block diagram, this is nothing but your single chip, nothing but IC. This is nothing but your IC. We call that as a single chip. Inside the IC, we have everything. CPU we have RAM and ROM. RAM and ROM is nothing but what? Your memory. Your memories. IO port is nothing but what? You need to connect input device and output device now. If you want to connect the input and output device, at that time we require these ports. IO ports. We call that as a IO port. Why we call? We in order to connect input and output device. Timer is nothing but, for example, let me take the example as my class. Okay, my class will start from 1:30 and it has to end to 2:20. Okay, after immediately whenever the value it reaches to the 2:20, timer it will send you the alert message. Whenever my time reaches to the 2:20, it will send the alert message so that I had to stop my class. Nothing but end my class. Okay, so here how can I measure? Using the timer peripheral. Timer is nothing but here the difference between, what is the difference? How many minutes? 2:20 minus 1:30. The difference between these two time is 50 minutes. Okay, this 50 minutes, the value of this 50 minutes I am going to store in my timer. Okay, timer it keeps on execute. First 50, 49, 48. When it reaches 0, it will start the alert message or alarm. It will send alarm so that I had to stop my class. So that is the job of the timer. Okay, not only nothing but what? Delay. Timer is nothing but it is going to measure the delay. Okay, along with the timer it has to not this the timer, the job of the timer is not only it is to perform the delay calculation, it has to perform, it will perform the counting operation also. It will perform the counting operation. That is nothing but we call that as a counter. Okay, two things it will perform. Timer it is going to perform the delay operation. Another one is counting operation. Counting is nothing but counter. Okay, in order to measure the counting the objects. Timer is nothing but, counter is nothing but in order to measure the counting the objects. Okay, that is also it is going to perform two things. One is counting, nothing but it acts as a counter. Other one is it is going to perform the delay operation. Delay operation is nothing but it has to it keeps on calculate the delay values. Okay, next is serial comport. Serial comport is nothing but, as I told, we have UART communication, that is wired communication, wireless communication. We have two types. Okay, I2C, all these are all CAN protocol, all these are all wired communication. Okay, all these are all wide communication protocol. Okay, these are the components that is present. All these components present in the single IC. That is what we call that as a microcontroller. Microcontroller is nothing but all the components that is present inside the single IC. That is the example for your microcontroller is 8051. 8051 is the basic microcontroller where it is going to where you are going to study means you can become expert in the embedded system. This is a 8-bit microcontroller. Okay, 8 bits microcontroller. This is okay. This is the basic and fundamental of your embedded system also. If you become expert in this, you can learn 16-bit easily, 32-bit. Okay, 32-bit also. Okay, so that these are the example of your microcontroller and what is the component present in the microcontroller. Is it clear?
Yes, sir.
Okay, you tell me what are the components that is present inside the microcontroller. Anybody can answer. What are the components that is present inside the microcontroller? Are you getting my question? Are you there?
Yes, sir.
Will you tell me what are the components that is present inside the microcontroller? Yes? Is it not clear?
CPU,
Timer,
CPU,
Yes?
RAM,
RAM
ROM,
and ROM,
Yes.
IO port,
IO port,
Yes. Okay, and what is the purpose of the IO ports?
Mechanism.
What is the purpose of IO ports?
it has input and output devices.
No, no, no. That is not. See, if I connect input device, your keyboard or mouse, those port will act as a input port. Output is nothing but if you connect printer or monitor or LCD device or LED device, if you connect, those pins will act as a output port here. Is it clear? IO port is nothing but that is the pin. Okay, there is no specific that this pin only acts output or this pin only act as an input. Okay, whenever you're going to connect the input device, these pins will act as an input port. Whenever you're going to connect the output device, those pins will act as an output port here. Okay, and what is
Yes,
the job of the CPU?
stores memory.
CPU. Kirti, you tell me what is the job of the CPU? Chetan Gowda, tell me what is the job of the CPU, what it is perform? Chetan Gowda, I think just you kept you just logged in and you're not following, I think. Just you logged in to my class and you're not focusing, I think so.
Instruction decode.
No, CPU is nothing but it will perform the arithmetic and logical operations.
ALU,
That is the main task. Okay, it's okay, no problem. Kishore, you tell me what do you mean by microprocessor? Kishore, Tell me what is microprocessor? I'm not getting you. Ask the same question for others. Manohar, you tell me. What do you mean by microprocessor? What is the main concept of the microprocessor? Manohar. Nitya, you tell me. What is the main component present in the microprocessor? Nitya N. Donisha, you tell me. What is the main thing of the microprocessor? Donisha? Satvik? Satvik?
Sir.
You tell me what is the main component that is present in the microprocessor?
CPU.
Yeah, CPU is the main component. And what are the components we require in order to make as a micro? If I want to perform any operations, what are the components?
RAM. Unified memory, sir. RAM.
Okay.
Media engine, GPU, anything.
IO ports, all timers, all these are external peripherals. Okay, all these are external peripherals. Okay, so let me conclude my session here. And next is what we will say. Yeah, the same thing, the difference between. Next is I'm going to discuss about the microprocessor and microcontroller difference. And next is the difference between hardware architecture and von Neumann and RISC CISC. Okay, and two things is remain. When you have internal, first internal.
Wednesday, sir.
Huh?
It's on Wednesday.
Can you extend assignment due date, sir?
Yes, sir.
Yes, sir.
Please,
Today
sir.
was the last
You have
day.
to- Yes, sir.
Sir, can we submit after internals?
Sir, please, sir.
Okay, I will.
Sir, after internals, you give
Sir.
3 or 4 days time, sir, for to submit.
2 days, sir.
What?
After
After
internals.
internal.
Okay, you tell me when you have when the internals will start.
On 2nd.
February,
Huh?
February, sir.
No,
From Feb.
exact date. Tuesday or Wednesday.
Wednesday, sir.
Wednesday, sir.
sir.
Wednesday to
Tuesday.
Saturday.
Saturday,
4
sir.
days you have. How many days you have
Saturday.
internal?
February 10th, we will submit, sir.
Yes, sir.
No, I will extend the assignment. I'm not asking about the assignment. You tell me how many days you have internals.
4 days.
When it will
4
start?
days, sir.
4
days, sir.
4 days.
When it will start?
From Fab 2 to Fab 5, sir.
2 to 5,
From
sir.
2nd to 5th.
Wednesday to Saturday.
Yes, sir.
Okay. 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 Wednesday you will start, no? Somebody Wednesday will start, no? Okay, I will revise. When I will revise the first module, somebody asked code, no?
Sir, from Monday you start
Tomorrow on
revision.
Yes, sir.
Monday and Tuesday, sir.
Monday, Tuesday,
Yes,
you can
sir.
revise.
Actually, maybe next week onwards it will maybe offline. That's why.
Yes, sir. Monday and Tuesday are
Sir,
in
Monday
online.
and
Sir,
Tuesday
Monday
in
and
online.
Tuesday is online.
Not sure. because they are telling
Ma'am told
because internal will be offline, no, that's why.
Wednesday will be.
Sir, internals are offline, sir.
But Monday you will not come to college.
No,
So ma'am told Monday and Tuesday are offline. Sorry, online.
Online, sir. Monday and Tuesday online, sir.
Okay, I will take Tuesday, that is revision class. Okay.
Sir,
Whatever.
Monday and Tuesday board you can take, no, sir.
But Tuesday I have 2 hours, no, that's why.
Yes, sir. You can revise it.
Okay.
What are the topics you want? You tell me, I will discuss them.
All, sir.
All is
Sir,
not.
important topics, sir.
Sir, from D type to synchronous, sir.
Okay, counters.
Yes, sir.
Yeah,
From
the
counter
assignment which you are given, sir.
register.
Counters and flip-flops. No?
Shift
Counters,
registers.
flip-flops. Yeah, shift register. Okay.
Sir, and
Yes,
JK
sir.
base tables.
Yes, sir. Bystanders.
Question, sir.
That if second module off and remaining logic gates you can study, I think that is much and that is easy, I think.
Yes, sir.
Yes, sir. Up to decoders, we can study, sir. After you can revise it.
From half of the second module. Okay. And that is enough now, or anything from first module also.
We will say, sir.
Okay, I will discuss about the what flip latches and this one counters. Okay, on Tuesday, and anything is there, you tell me.
Okay.
Yes.
Okay, let me call that.
Sir, when we have to submit, sir?
Okay, I will extend.
Assignment. Okay, sir. Thank you, sir.
February 10th, sir.
Okay.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.
Okay, okay. Okay, let me call the attendance. Okay, so let me answer to my attendance. Adam,
Present, sir.
Aishwarya,
Present, sir.
Akash,
Present, sir.
Akhilesh,
Present, sir.
Akhilesh, Akhilesh,
Present, sir.
Ketan Gowda is answering, not Akhilesh.
Sir.
Akhilesh, I am
Sir,
asking.
he can't unmute his mic, sir. He is in the meeting. Sir, he is in the meeting, sir, but he can't unmute his mic.
Which meeting is?
Sir, in your class only is there, sir, but he can't unmute his mic, sir.
Okay, okay. Adwa,
Present, sir.
Anusha,
Present, sir.
Kirti,
Present, sir.
Bhargav, Bhargav. Okay, Bhargav is absent. Gayavardhan, Dinesh. Dinesh is absent. Okay, Chaitanya, BS.
Present, sir.
Chandan Kumar. Chandan Kumar.